Namaste. Welcome back to our channel Victorious Study of Chemistry. Today we discuss about electron configuration of elements. In previous class we discussed about matter. Matter undergoes two classifications. One is physical classification and second is chemical classification. In chemical classification, matter can be broken down into two categories: pure substances and mixtures. Pure substances are further broken down into elements and compounds. Let's go to our topic. Today our topic is electron configuration of elements. First we know about what is called element, and next we know about what is the electron configuration of elements. First we will learn about what is called element. What is called element? An element is a substance that cannot be broken down into any other substance. Here the term substance is a form of matter. It is composed of one type of atom or molecule. From this, the term element is a chemical substance and it is made up of particular kind of atom and cannot be broken down into any other chemical substance by a chemical reaction. Next question, what is the electron configuration of elements? What is the electron configuration of elements? In atomic physics and quantum chemistry, the electron configuration is the distribution of an element or molecule in atomic or molecular orbitals. In atomic or molecular orbitals. From this, the electron configuration of an element, describes how electrons are distributed in its atomic orbitals. For distribution of electrons in its atomic orbitals, we follow Moeller chart or Moeller diagram. This chart was designed by a scientist, Moeller. So it is called Moeller diagram or Moeller chart. Here we see Moeller diagram. In Moeller diagram, N describes about shells, L describes about subshells. These subshells have orbitals, orbitals have electrons, electrons have spin. This total concept explained by using quantum numbers. There are 4 quantum numbers. First one, principal quantum number. Second one, azimuthal quantum number. Third one, magnetic quantum number. Fourth one, spin quantum number. First, we discuss briefly about quantum numbers. First quantum number is principal quantum number. First one, principal quantum number. It is denoted by letter N. Principal quantum number denoted by letter N. N is equals to 0, 1, 2, 3 and so on, where N is an integer. It describes energy level. It describes about energy level or shell or orbits. First, what is called shell? The electrons are distributed over different energy levels. These energy levels are called shells. These are designated by letters K, L, M, N and so on. These are designated by letters K, L, M, N and so on. But scientists have named these shells using quantum numbers. Each and every shell has its own quantum number. For K shell, principal quantum number is 1. For L shell, N is equals to 2. For M shell, N is equals to 3. For N shell, N is equals to 4 and so on. K is lower energy level. Next higher energy level is K. Next higher energy level is M. Next higher energy level is N. These all shells do not have same number of electrons. For maximum number of electrons in a given shell, we calculated by a formula 2n square. 2n square, where n is shell number. For K shell, maximum number of electrons are calculated by a formula 2n square, where n is shell number, n is equals to 1. So 2 into 1 square is equals to 2. K shell have maximum number of electrons are 2. For L shell, maximum number of electrons are calculated by 2n square. 2 into, here n is equals to 2. 2 square, that is equals to 2 into 4, that is equals to 8. For L shell, maximum number of electrons are 8. For M shell, maximum number of electrons are calculated by formula 2n square. 2 into, here n is equals to 3. 3 square, that is equals to 2 into 9, that is equals to 18. Here maximum number of electrons are 18. For N shell, maximum number of electrons is equals to 2 into n value 4 square, that is equals to 2 into 16, that is equals to 32. For N shell, maximum number of electrons are 32. This is principal quantum number. Second one, azimuthal quantum number. Second quantum number is azimuthal quantum number. It is denoted by letter L. L values are 0 to n minus 1. It describes the subshell. What is called subshell? The secondary quantum number divides this shell into smaller groups of orbitals called subshell. We have shells K, L, M, N and so on. Each shell have principal quantum number. For K shell, n is equals to 1. For L shell, n is equals to 2. For M shell, n is equals to 3. For N shell, n is equals to 4. These shells subdivided into subshells. These are designated by letters S, P, D, F and so on. These subshells have azimuthal quantum number. For S subshell, L is equals to 0. For P subshell, L is equals to 1. For D subshell, L is equals to 2. For F subshell, L is equals to 3. From this, if L is equals to 0 is called S subshell. If L is equals to 1 is called P subshell. If L is equals to 2 is called D subshell. If L is equals to 3 is called F subshell. Here we note 2 points. Each value of n have multiple values of L ranging from 0 to n minus 1. I repeat it again. Each value of n have multiple values of L ranging from 0 to n minus 1. This is first point. Next point is The number of subshells for a given shell is equal to its principal quantum number. Its principal quantum number. Let's see. For K shell, n is equals to 1 and L is equals to 0. From this, resulting subshell is NS. Here, number of subshell is equal to principal quantum number. So, number of subshell is 1. Next, L shell. For L shell, n is equals to 2 and L ranging 0 to n minus 1. From this, L values are 0 and 1. If n is equals to 2, L is equals to 0, resulting subshell 2s. If n is equals to 2, L is equals to 1, resulting subshell 2p. From this, number of subshells is equals to principal quantum number 1, 2. So, number of subshells are 2. For M shell, n is equals to 3 and L ranging from 0 to n minus 1. So, L is equals to 0, L is equals to 1, L is equals to 2. If n is equals to 3 and L is equals to 0, the resulting subshell is 3s. If n is equals to 3, L is equals to 1, then the resulting subshell is 3p. If n is equals to 3 and L is equals to 2, then the resulting subshell 3d. Total number of subshells is equals to principal quantum number. So, total number of subshells are 3. For N shell, n is equals to 4. L values are 0, 1, 2, 3. Available subshells are 4s. If L is equals to 4, L is equals to 1. 4p. If L is equals to 4, L is equals to 2. 4d. And if n is equals to 4, L is equals to 3, then resulting subshell is 4f. Total number of subshells is equals to its principal quantum number. So, total number of subshells are 4. Is clear? Third one. Magnetic quantum number. It denoted by letter M, R, ML. Magnetic quantum number values are started from minus L to 0 to plus L. It specifies the orientation of an orbital. Orientation of an orbital. Third quantum number divides the subshell into individual groups of orbitals. For example, S subshell divided into individual orbitals. P subshell divided into individual orbitals. D subshell divided into individual orbitals. And F subshell divided into individual orbitals by using formula 2L plus 1. By using this formula, these subshells are divided into individual orbitals. These orbitals having electrons. Maximum number of electrons in a given subshell is calculated by a formula 2 into 2L plus 1. 2 into 2L plus 1. Formula for number of orbitals in a given shell is 2L plus 1. Formula for maximum number of electrons in a given shell is 2 into 2L plus 1. Let's see. For S subshell, first we calculate number of orbitals is equals to formula 2L plus 1. For S subshell, L is equals to 0. That is equals to 2 into 0 plus 1. That is equals to 1. Number of orbitals is 1. Next, this one orbital contains electrons. Maximum number of electrons for a subshell is given by a formula 2 into 2L plus 1. 2 into, here 2L plus 1 value is 1. 2 into 1, that is equals to 2. So, S subshell is divided into smaller groups called orbitals. S subshell have one orbital. This one orbital contains 2 electrons. This one orbital contains 2 electrons. Next, P subshell. First we calculate number of orbitals. 2L plus 1. For P subshell, L is equals to 1. That is equals to 3. Next, maximum number of electrons. 2 into 2L plus 1. That is equals to 2 into 2L plus 1 value 3. That is equals to 6. So, P subshell containing 3 orbitals. These 3 orbitals have 6 electrons. Next, D subshell. Number of orbitals is equals to 2L plus 1. For D subshell, L is equals to 2. 2 into 2 plus 1. That is equals to 5. So, D subshell have 5 orbitals. These 5 orbitals contains maximum number of electrons is equals to 2 into 2L plus 1. 2 into 2L plus 1 value 5. That is equals to 10. So, D subshell have 5 orbitals. These 5 orbitals contains 10 electrons. Next, F subshell. Number of orbitals in subshell. F subshell 2L plus 1. For F subshell, L is equals to 3. So 2 into 3 plus 1, that is equals to 6 plus 1, that is equals to 7. Maximum number of electrons. 2 into 2L plus 1 value 7, that is equals to 14. F subshell have 7 orbitals. These 7 orbitals contains 14 electrons. Is clear? Fourth one, spin quantum number. Fourth one, spin quantum number. It is denoted by letter MS. MS values are plus half or minus half. It specifies the orientation of the spin axis of an electron. Orientation of the spin axis of an electron. An electron can spin in only one of two directions. Spin up or spin down. This is about spin quantum number. Finally, we see filling of atomic orbitals. Filling of atomic orbitals. Atomic orbitals are filled by using 3 rules. First one, Aufbau Principal. Second one, Pauli Exclusion Principal. Third one, Hund's rule. First one, Aufbau Principal. Second one, Pauli Exclusion Principal. Third one, Hund's rule. First one, Aufbau Principal. According to this principle, electrons first occupy lower energy orbital than occupying higher energy orbital. Next, Pauli Exclusion Principle. According to this principle, each orbital contains 2 electrons. These 2 electrons have opposite spin. Third one, Hund's rule. According to this rule, in a given subshell, each orbital is first singly occupied by electrons before pair up. Let's see some examples. Hydrogen, carbon, neon. Hydrogen atomic number 1, carbon atomic number 6, neon atomic number 10. Electronic configuration of hydrogen. First, electron enter into a subshell. Ns 1. For carbon, first electron enter into 1s. In S subshell contains one orbital. That one orbital have 2 electrons only. So 1s 2. Third electron enter into 2s subshell. 2s contains 2 electrons. Remaining 2 electrons enter into 2p subshell. Remaining 2. 1s2, 2s2, 2p, 2. Next neon. Neon atomic number 10. First 2 electrons enter into 1s subshell. Next 2 electrons enter into 2s. Next electron enter into 2p. P orbital, p subshell having 3 orbitals. 3 orbitals having 6 electrons. So remaining 6 electrons occupy p orbital. This is today's video. If you like this video, please like, share and subscribe our channel, Virtual Study of Chemistry. Thank you for watching.